All right, everybody. Welcome back to some Living Freestyle Game Dev Ask Me Anything Q&A. My name's Kevin. We do this twice a week. If you want some context on what we're doing, you can always go back and look at the intro. Right now, we are looking at AI. We're trying to work with AI. We've been running into some problems with the gameplay ability system, but I'm super excited because I think I found a bunch of answers that is going to help us out with a lot of those things today. So, as always, questions take priority. If we run out of questions, then I just fall back and I work on the game that I've been building and working on. I think one of the things potentially worth noting is I am considering doing a little bit more random just live streams whenever. We'll keep with the schedules Sundays and Wednesdays, but there's a bunch of this stuff that I'm just really excited to work on. And rather than going and recapping, it may just be easier just to stream those out when I do get a chance to work on those things. So for those that are here or those that are watching, thanks for watching. And let's just kind of hop straight into Unreal because at this point, it does not look like we have any questions. And I didn't see anything posted in the comments. For next time, if you have any questions, throw those in the comments down below and I'll try to get back to those later. In the meantime, let's get back to some AI and the gameplay ability system. So back to Unreal. It looks like everything is good to go. All right, if you recall where we left off, we were having problems with our damage sense. So when we play, when we shoot an enemy, when we would shoot them, oh, he saw me. You can see up in the left, it's printing sight is true, but damage is false. So we weren't getting what we needed. But I don't know if you just saw that. It actually just sensed damage. So what I was saying was, what I found was that originally damage sense had not been configured if you went back about 2 years. And sometimes it's possible that those things aren't true or truly aren't implemented the way you would expect. But I actually found another forum post somewhere where it turns out, despite what the documentation says, you have to have your damage sense, your AI perception on the AI controller. Let's take a look at our controller here real quick. So here's our ALS AI controller. Actually, that's not the one I wanted. Oh, it is the one I wanted. So what I did is I added the actual damage perception to the AI controller. Basically same general settings. I've got my senses and then I have my damage. It's pretty straightforward. The cool thing though is that because our damage, because any perception that gets updated comes through and will actually, it'll actually just print off a string, but it basically just gets the sense. You'll notice now that even when I just damage an enemy, well, that time you just saw me, but that actually is showing you one of our problems. We got a couple problems that we're going to be fixing tonight. So he's walking the other way. He saw me. Hold on, I got to switch to my mouth here. All right, let's kill that guy. So what we were fighting before is they didn't see us. We need one of these dudes to land facing the wrong way. It's funny. All last week, all they did was land facing the other way. If I shoot him without getting seen, oh, I killed him. Actually, that points out an issue. Oh, come on, guys. Somebody spawn facing the other way. Here, let's try hiding back here. Okay, so I'm going to describe to you the problem that's happening that we do need to fix for sure. There we go. Damage the sense and he came running right toward me. It took a second, but it didn't even take a second. It was almost instant. The minute he sensed it, even before sight, he actually came running for me, which is cool. Hey Zem, the Tem, how's it going? We're working with Unreal, and you can see right now, this dude, right when I shoot him, he senses it, comes running at me. So we finally are at a point with our AI that the enemies are sensing damage and they come running the minute they sense the damage. But I want to show you the problem that I was having, which was as a result of all these changes that we made to the gameplay ability system. I'm going to shoot over here like 4 or 5 times and then shoot him once. Did you see how he died instantly? It's because what's happening is all of the missiles, even if they miss, when they do finally hit, it's taking all of the projectiles and applying it to the enemy all at once. Just double checking the chat for any questions. And so as a result, what's happening is we're doing all kinds of extra damage that we shouldn't be doing. All these bullets that missed one time, there's like 400 hits there. Add a crouch to stay stealth. Well, we do have a crouch, if I can remember how to trigger it. Oh, wait. No, it's not that one. I always hit crouch on accident. Oh, there it is. So we do have a crouch. Now, interestingly enough, we have not added in hearing. I think we can add in the sense of sound as well, but for now, for what we're working on, damage and sight is going to be just enough. But, so 2 things that I want to fix now, actually, that we broke. If you'll notice, see these headshots? I'm shooting this guy in the head, and he's not actually dying. So we broke headshots. The only thing that's working now is, yeah, when the bullet hits the wall, we can do that. But actually, I'm going to try to do it a different way, actually. All right, so we got 2 things to fix. We got the headshots, and we have the multiple damage. So let's go back to our projectile and take a look at what's coming in. So we're sending the gameplay event to the actor. La-di-da-di-da. What I'm going to do is, as part of the gameplay data from my projectile, and I'm not totally convinced this is the best way to do this, but I'm also going to send the projectile itself to go with it, so that when we get to the gameplay ability for projectile base, what I'm going to do in here is I'm going to check to see if the projectile that's doing the damage is the one that is actually coming through as part of the gameplay data. And so, inability report damage, apply gameplay effect to target. So we got 2 things to do in here. One is, remember, we broke headshots, and 2, we need to fix our missile stuff. So let's see here. Here's a payload. This is our asynchronous task. Self. Get a reference to self. Let's see if that equals this guy. Actually, what we want is not self. What we want is spawned projectile. So if the spawn projectile that's part of this gameplay ability is the one that is actually coming through as part of the event data, then I'm actually going to do the damage. So if that's true, then I'll apply the gameplay effect. So let's just test that real quick. There we go. 1 shot, 1 damage. That's what we wanted. So basically, we're just checking that the projectile that is doing the hitting is the right one. Now you can still see the headshots aren't working because we're getting the VFX for the headshots, but we're not actually getting the damage for the headshots. So let's go back to that same blueprint and fix that. And it's pretty. It should be pretty easy to track down because what we're doing in here is we're waiting for projectile hit. How did headshots work normally? You mean before I broke them? Or you just mean in general? Thanks for asking all the questions. Basically, the way I have headshots working, okay, before they broke, what was happening was the projectile was applying base here. Actually, I can go back and show you where it was. All right, so in here, you can see if the hit bone is the head. If I'm hitting the head, then what ends up happening was it will play a different V effect depending on whether or not you hit the head or not. That's where we're getting our head sparkles from. And so what we were doing in here was, you can see we were setting our event tags to headshot versus projectile hit. And so we were applying the gameplay effect in here, which I think was actually the wrong place to put it. And so as a result of that, all we do now is we send through this projectile hit gameplay tag. We send through whatever the tag is, but then once we send it and we receive it, you can see here in our receipt, we're only checking for projectile hit. We also need to check and do something for a headshot. So let's do that. So let's see here. We're waiting for the gameplay event, projectile hit. And what we can do is we can duplicate this. We can duplicate this entire structure. Control C, Control V. We love the copy paste. And what we're going to do is we're going to rewire this a little bit. So, and actually I think we'll just move these down just to make it clearer. Okay. So what's going to happen is we're going to come in, we're going to wait for a gameplay event, and we're going to change this to be the headshot. All right. So now we're checking for the headshot. Then we're also going to just keep going. That's what this top pin does. I never worked in Unreal before, but I think you should make the headshot and the normal hit different sections. They are different sections, I think, if I'm understanding. The headshot is just the head portion of the character, and or you mean different areas of blueprint, as opposed to different sections of the body. But basically, we're just waiting for a hit, right? And if we get a headshot, then what's going to happen is we're going to come in and we're going to do the same thing we were doing before, but the difference is what we want to do is, instead of applying base damage, we're going to apply heavy damage. We'll still report our damage event, and then we'll still in the different areas of the blueprint. That's fair. And we'll basically do we'll end the ability. And then we're also going to check, we're also going to continue on and add in a different wait gameplay event, which is waiting for just a normal projectile hit. If we get that, we come through and we apply a normal damage. All right. And then also we put in a 2-second wait on the projectile, which again, if you recall from last time, potentially something to think about if we're doing sniper rifle shots and it takes longer than 2 seconds for the bullet to get there. Just watch for projectiles ending early, just something for future me to worry about. But then we'll end the ability. So overall point is, now we're checking for headshots and we're checking for regular projectile hits, and we're applying the damage based on that. So let's just compile and save that. And we should be able to test it pretty quickly. Headshot, 300, heavy damage. That's exactly what we want. And let's check our normal hits. Yep, those are good too. So we're actually in a pretty good place to kind of get back to more of what we were working on with our AI. 25 shots, 1 shot, 1 kill. Perfect. And he's running away. So let's take a look at just how the behavior is working now that we're kind of back at a good baseline. So he's gonna come fight me. That's great. Whenever I run away from him, because he's still in melee fight mode, he'll come running to come and get me. And you can see these 2 green spheres. He's going to find a position around me within those green spheres to attack me. Now, he can't attack yet. We'll add that in later, but that's okay. Then if I shoot him twice, his health goes low and he runs away, just like we would expect. Now, same thing as before. We're just double checking to make sure all the stuff still works, where he will pick spots that are further away from me when he runs. right? He should not be running past me if at all possible. So he'll basically end up backing into corners. And then eventually he'll just kind of get in the corner. Not yet. No health regeneration yet. We're just testing AI at this point. But overall, this is looking pretty good. Now, there's a couple things that I would like to be a little bit different about this. First, we're going to clean up some of the printing stuff that we put in there, like that the sensing and everything. And then the other thing that we're going to do is, what I'm thinking is, you can see when he gets to a spot that's, all right, let's see if I can show you what I'm talking about. If we're close by, he waits a pretty long time before he runs away. I'm pretty much standing right next to this dude. It's a pretty long time. It's, what I'd really like is, what I'm thinking is, let's kill him, I'm going to show you the reverse of that. When he's unhealthy, when he's hurt, what I want is I want him to run away sooner the closer he is. And when he's healthy and he wants to come fight me, I don't want him to wait so long to come fight me. So what I'm thinking is we can add in a distance-based wait. So that might be something we can add in that will make this feel a little bit better. So to do that, mantle update, set mantle target. All right, well, that's something in the AI system. All right, so these are all the print strings. First, let's clean this up. We don't need this. We don't need this. We don't need this. None of these are connected. Switch on int. This is literally just printing out the information from our stimulus. Okay, cool. So that should clean up some of those print statements. That's good. Now, how are we going to do a distance-based wait? Let's take a look at our ability our AI tree here. Here's our enemy AI tree. Okay, couple things that we can do. If you recall last time, we were adding in this look for damage task. I believe we can get rid of this. Just to make sure, we were doing a print string on the recent damage. Yeah, I think we can get rid of this. I don't think we need this anymore. So let's just get rid of this from our ability tree. We were kind of putting it everywhere because the damage sense wasn't working. And so we were trying to kind of like cheat it. But I'd much rather not cheat it. So, especially since now that it's working. All right, I think we got rid of all those. We got rid of all those. We got rid of all those. Okay, cool. So now when we're going to fight, we're kind of going through a bunch of stuff. We'll get into tell friends stuff a little bit later because right now we're just working with one enemy. We're setting our sight. We're setting our gate. We're updating our current attack position. We're moving 2. We're doing running gate. Here's our wait. This is where we finally do our wait. Okay, and right now it's just a flat 2-second wait. What I'd really like is I'd like to do this based on distance. So the problem with the current wait is that I really only have 2 options. Wait time of 2 seconds or random deviation and a random deviation to it. I'm curious if we open up wait, can I see what's going on in here? Doesn't look like I can. Node name, 2 seconds. Let's see if we can find the wait task. This may actually be a little harder than I thought it was going to be. So this is our wait for the fighter. That's fine. And then if we look over in the flight, this is our wait, which is 4 seconds with a plus or minus 2 random deviation. I would have expected that if I double clicked on this, I could see this in code. Let's go back and take a look at our tasks. And we're going to add in a new task. And what we're going to do is we're going to call it distance-based weight task. I have no idea if this is going to work. All right, now we need all of the normal AI execute stuff. We're going to get rid of this because we're starting from 0 here. We are going to need to finish execute on this. Finish execute. Okay. I'm going to get rid of this pawn. All right, so in order for this to work, what we need is we need to know the distance to the last target. And if you recall, actually you probably don't recall because we've never actually talked about this. We have in our blackboard our last enemy location, I believe. So we should be able to get from the blackboard the last enemy location. Which is a vector, which is here. So we're going to get the value of that as a vector. Get the value as a vector. We're going to put that in there. And then because we're in debug mode, I am going to draw a debug sphere for this thing. And let's make it yellow. And we'll give it a duration of 5 seconds just so I can see. Oh, that was the wrong button. Do not like that button. All right, I accidentally triggered a breakpoint in code. 1 second, center radius. So we're gonna start with just drawing a sphere at our last location if we call this. Oh man. We'll mark this as a success. Compile this and save it. And then for our fight character inside of our behavior tree, what we'll do is over here, just before this wait task, we'll put in a new task called distance based wait task. Now, this task doesn't actually do anything yet. Let's see if we can make better room for this. Or it definitely doesn't do what it describes yet. We're just testing to get this to work. And the goal is to hopefully replace this wait with this distance-based wait. But as long as we're in fight mode and we're a melee character, the enemy's a melee character, he should come running at me, and I should see his yellow sphere of where he thinks I last was. Or it's white, actually. Wait. Hold on. Let's try this again. Where you going, buddy? Not convinced. Oh, there it is. Oh, interesting. The last known location is the last. Okay, so the last known location is where I was last. That's the wrong variable. That's where he last saw me before he lost line of sight. So that's not the variable we want. We need to see what we're actually. Update current attack position. Let's see what we're using in here. Oh my goodness, this blueprint is messy. We need to clean this up. Holy shnikes. Okay. AI actor. We're getting the actor location. And we're going to draw a bunch of stuff. Whatever. Set the floats. Ranged. Find a spot. attack position. Blackboard. Last enemy location. What are those white spheres that are printing? Is there a magic untangle button to auto-format sphere? Yes, there is actually, Danny McGee. So for example, actually I love it. So there's two things that you can use. One, there's a download you can get. I have not actually downloaded it, but it's actually a layout tool. I forget where it is, but I know some people have had success. But just from a normal hotkeys with Unreal, this is something that I'll do a lot. So for example, let's just say that we wanted to clean this up a bit. I'll grab all of these, move these in line. Let's move this down just so we can kind of see what's happening. And then I'll get to a point where it's mostly working. It's mostly lined up, but you'll see like these two, like for example, these two are off center, right? What you can do is if you pick two of them and press the Q key, it will line up the ones that you have selected. So if I take these and they're all off cattywampus center, and I just pick three of them and press Q, it lines them up. Hopefully that helps. But in this case, I'm not going to worry about these spheres. I'm going to keep these spheres for right now. Let's see if we can find. We're going to do a search for draw debug. We've got a lot of debug spheres in here. That's a red one. None of this is connected. What was this connected before? We're not going to worry about it. We're going to delete it. Now we have 3. So here's the white one. Attack position. I wonder. Location check. This is last enemy location. That is what we're using. We're using last enemy location, aren't we? We are. But it's only updating. I'm expecting that to draw. Oh, actually no, this makes sense. I was wrong. It's not when I lose sight. It's when the enemy decides to wait. So when he stops and starts waiting, that's when he's going to do it. And what we want is if he's far away. Okay, cool. So that is actually working. That is the right variable that we want to use. So if we go back to this, our sphere's drawing fine. Now the thing I want to see is there a wait available for us in here? Gameplay tasks. Blackboard. Wait. Task wait delay. Wait a specified time. This is functionally the same as a standard delay node. What is this? Interesting. What category was that under? Gameplay tasks. No, that's not what we want. I think that's the gameplay ability system. So this thing, wait for a specified time when executed. Let's see here. Let's check one other way. We're going to remove our context sensitivity here. Wait. Functional. Get wait for nav mesh. Get player is waiting. Wait for loading. Task wait. That's not what we want. You know what? I think we could probably just do it with... let's try a standard delay node and see what happens. So we're going to add a variable in here called wait time. It's going to be a float. And we are going to make it editable, and we're going to expose it on spawn, compile and save. And then what should happen is in this AI tree, distance-based wait, you can see our wait time is now exposed for us to use. So that's what we want. And again, for those that missed last time, if I'm on the ability tree and I'm going back to my thing, Control Tab will let me quick flip back and forth between the two. It makes it a whole lot easier when you're working with a single monitor, just as a general heads up. So what I actually want to do is, with this value, what I want to do is I want to get the distance from where I am. So let's get actor location. So we get our location, and then we'll calculate the distance between our location and that location. And then let's see, how do we normalize this to make it nice? Let's just say that if we're within, let's say that if we're 5,000 units away, and okay, hold on, let me think about this. If we're 5,000 units away, we don't want to wait much at all, unless we're doing it for we're hurting. And if we're 5,000 units away, we would want to do it. So we're going to get that distance. And with that distance, let's divide by, yes. Okay, so divide by, let's bring this back up. Float by float, and let's just say 5,000. Okay, and we're going to get our wait time. And we're going to multiply that times float times float. Okay, so if we are 5,000 units away, we're going to divide by 5,000, and so our wait time is going to be the full wait time. All right, now this is a little backwards because I'm actually thinking about it in the case where we're unhealthy and the enemy is running away. So what that means is if we're 1,000, like let's just say we're like 1,000 units away, so our wait time is going to be 0.2, so we're going to move away more. So what we want is we want to be able to invert this. Okay, and so let's add another variable here. I'm making this up as I go. So how do we make this obvious for when we're using it though? If I just create a variable here called invert, future me is going to forget what that means. So distance-based wait, that's what this thing is. If we're far away, we're going to wait for, right now if we're far away, we're going to wait for the full time. If we're close, we're not going to wait at all. If we are, and what we want is if we're close, we're not going to wait. So that's the health version of it, right? That's if we're unhealthy, we want to get away fast, and once we're away, we're willing to wait the whole amount of time. Okay, so if we're attacking though, we basically want the inverse of that. So we could just call it attack mode. Invert for attack mode. That's what I'm going to use for right now, just because I can't think of anything else. Because then it'll be clear. Invert for attack mode. Whew. And let's just make that a Boolean. And let's instance editable and expose that on spawn. Compile save. All right, we're going to get this. And if this is true, okay, so quick add, another quick little tip. If I hold B and left click, it'll automatically create a branch node for me, so I don't have to type that out or anything. Another one of my favorite ones is control and alt clicking. If I alt click a link, it'll break it. If I control click, it'll allow me to move it. So I can just move this over without having to scroll over here, drag it over here. I can just control drag and do what I need to do. So if we're inverted for attack mode, what I want to do is I want to take this and say divide. So here I'm going to alt click and I'm going to say 1 divided by that. And then if that's true, then I'm going to delay. And the duration is going to be our wait time times our inverted mode. Okay. And then if we can actually get rid of this debug sphere now. And if it's not, then our delay is going to be just straight up from the actual deal. Now, I don't know if putting a delay in the AI tree is a good idea. There may be a better way to do this. And I'm going to have to do some research on that. But in the meantime, let's just give it a try. See what happens. So what I want to do again for sanity, I'm going to put in a print string just so I can see it. Print string. And this is going to be attack weight. And I'm going to, just for kicks, we'll put in a flight weight. Okay. So now what this is actually going to do is we're going to now have a double weight theoretically. There's going to be a weight here and a weight here. I don't know if this actually is going to, I think this will work, and here's why. Because we're not actually going to finish the execute till after the delay. And we're going based off of 5,000. I'm going to change this to something a little bit closer. Let's try 2,000. And let's go. Oh, wait. I didn't actually check what it was set to. So here's our distance-based wait. We're going to invert for attack mode, and we're going to set our wait time to, let's make it long. Let's make it 5 seconds. Okay, let's try this again. All right, so attack mode. He doesn't know I'm there. Sure is a long time he's waiting. Attack weight. Wow. I'm not sure if we got that right. Let's change our print. Let's actually print our wait times instead. Let's use an append string, and what we'll do is we'll say attack wait with this semicolon, and we'll set that to that. Same thing down here. False. This is going to be flight weight is going to be just straight off of that. Plug that in here. And let's go again. It's not helping me when he's up top like that. Alright, sense damage, 1 shot. No bueno. Alright, he gets to the weight, attack weight, 10 seconds. That's fine because he was close. The problem is he's not close anymore. Attack weight is 1.6 seconds now. Then he waited 1.6 seconds. Okay, so we can see what's happening. He gets here. Now attack wait is 9 seconds. He's going to sit there for 9 seconds, whether or not I move away or not. We're going to have to tweak this a little bit. We're going to need to make this interruptible. So then the attack wait drops to 1.8 seconds, which is much more reasonable. And then here he's going to get in. That was weird. Attack wait went to 14 seconds when he was standing right next to me. I'm expecting a low. Oh, actually, no, we want to, this should be a high wait time. 8 seconds. "13 seconds. That makes sense because we don't need him to work. All we need though is if I move away. The problem is if I move away, then we need to update that. We need to think about how we're going to do that. Okay, well, the attack weight is working in the sense that it's inverting. But the problem is we come in here and we're basically stuck in here. I'm trying to think. What I'm trying to think of is I'm trying to think of how we can interrupt this wait if the character moves away. And one thing we could do, because see, we have interrupts on these other things. For example, if while the character's healthy, he's going to move. While the enemy's healthy, the enemy is going to move towards us to attack. If that changes, you'll notice that it, oh, actually, it doesn't abort. I thought it did abort. Hold on a second. Let's test that. That should be a first priority. If this dude is running towards me. Yeah, that worked. He ran away. Interesting. How's that working? As long as he's healthy. Has line of sight. Okay, so this is where the aborts if it's healthy. Okay, that's the decorator. So in here, what we want to do is we would want to abort. We're going to update the last known target there. We're going to set our focus. We had line of sight. Update current attack position. So we're constantly updating the attack position when we're in here. And to do that, oh my goodness, this is this crazy blueprint that we have. What a spaghetti mess. Past me was not very nice to future me. Okay. No bueno. That's where one of those prints are coming from. Why is that no bueno? We'll have to figure that one out in a second. Finding a new spot. Spot found break. Getting our last locations. This is not connected to anything. That is, all right, so we come in here, we draw a thing, we go through a sequence. If the character is ranged, we're going to get a random location somewhere within the range of the character. I'm ignoring range because we're only working with melee. This is going to basically create the spear position to create the rings. When it's completed, we're drawing the white sphere, which is the attack position. So the green spheres is the rings, and the white sphere is the final attack position. And then once we have drawn the attack position, if that's where we do a distance test to see if one is greater, do we need to find a new spot? So if the distance vector compared to where we were was find a new spot, then we do location check, and then we're updating our attack position with the location to check. And that is if the distance is less. If that's false, we're going to find a new spot. And when we go to find a new spot, that is basically re-triggering this thing where we're going from 0 to 10. We're getting random locations within the navigable radius, and we're checking to see if it's in there. Okay, so this is constantly looping through and trying to find spots. We either need to test, which I don't like because the whole point of this is distance-based weight. What we really want is we want this to break because the enemy's gotten too far away. Update last known from target. What does this do? Man, this is another spaghetti mess. We can clean this up while we're in here. I have not touched this stuff in so long. I've learned quite a bit about cleanliness of blueprints in the meantime. Let's see if we can make this a lot more friendly and easier to read. Gonna be our execute finished. I'm just double clicking to add these knots. All right, so this is a good example of it would be nice this just read a lot cleaner. Oh, we got two of them in there now. We don't need two. Let's just unconnect. That was that alt click I told you all about earlier. All right, we're dragging and dropping. Okay, so this is now cleaned up. Now, what is this thing we're doing? Update last known from target task. Okay, so target actor. Get the value. Oh, interesting. We're checking out as a hero. And then if it's a hero, what we're going to do is we're going to set the last enemy location and we're going to set the move to location. Interesting. So if the last known location changes while we're waiting, by more than a certain amount, I think would be the thing that we wanted to do. Then we would want to stop waiting and do the next thing. So let's take a look at that. In our distance-based weight task, what we really want to do is see what decorators we can add. Cooldown, time limit, blackboard. Conditional loop, that sounds interesting. Is at location. What does a conditional loop do for us? Query. Oh, interesting. Oh, I see. So what this will do is this will continually check to see if the move to location is set. That might be an option. Let's see what else we got. We created our own Compare blueprint entries, compile conditional loop, cone check. Cooldown is at location. Oh, that might work. Is at location. And the location that it's at is the move to location. Okay, it's similar to that. It's going to be similar to that. But we don't want... What we really want to know is if we want to know, has target moved? That's the blue. That's the decorator we want. Has target moved? And I don't think that one exists. Time limit, keep in cone, is BP entry of class. Okay, so let's just double click on this, is at location. Nope, can't do anything with that. So let's see how we created our own before. Because we definitely created our own. So here's our own ability tree decorator is healthy. And here is has friends. Let's take a look at has friends. Perform condition check AI. Same thing, man. I not even keeping these straight. Let's clean this up while we're in here. So there's a good rule that we have at work. Leave every blueprint cleaner than when you found it, if you have the chance. And since I'm the only one working on this, that is all on me. Okay, so I think that's helpful, or that's done. So this comes in deleted to return value of true or false. Okay, so here's what we can do. Let's go back and let's duplicate this guy. And actually we can save it first, now that we've done that cleanup. So save. And let's duplicate this, and we're going to call this has target moved. Okay. And in here, what we want to do is observer activated, I believe. Perform condition check AI. Nope, that's not what we want at all. This is what we want. Perform condition check AI. Okay, and then what we're going to do is we're going to get that blackboard, which is all of this stuff. So we're going to get the enemy's blackboard, and with that blackboard, we're going to get the target actor. Okay. And we're going to double check to see if that target actor is the enemy, or I'm sorry, the hero. Okay. And if it's the hero, what we want to do is get actor location. And we're going to compare that to the last known location. And so from this blackboard, we can also get another value. Get a value as vector. And we need a key name for this one. And that's going to be, I believe it should be that last known location. Distance-based weight. Last enemy location. So this is our last enemy location. And what we're going to do is we're going to do this if we're within some kind of tolerance. But what we could, yeah, let's do that. So let's just get, that's the target actor. We're going to get that location. And let's get our distance. Okay. So we're going to take the last enemy location and the target actor, and we're going to check their distances. Because the last enemy location and the target actor should be the same person. And if it hasn't moved, the hero basically, or the champion, if they haven't moved, the distance should be small. So if this value is less than, let's say 50, just to be safe. If it's less than 50, then they have not moved. Okay, so if it's less than 50, they have not moved. And if they have not moved, then this is going to return false. So basically, if they haven't moved, then we're returning false because it has target moved. It's false. If the distance is greater than 50, then what we're going to do is we're going to say, yes, the target has moved. Or if for some reason it's not set, like this cast failed, then we're going to say it didn't move. So now let's print out a string, another string, and this one's going to be target moved. Target moved. I'll save. And then if we go back to our blueprint, our distance-based weight, we should be able to add a director. Has target moved. And observer aborts self. Node name. Okay, let's see if that works. All right, so we're going to come in. Target moved. That's not working quite the way we'd expect it to now, is it? All right, so either we have this inverted. Yeah, it's inverted. Okay. So target moved. It's interesting. So we want the false. Oh, if it's less than 50. No, that's right. We printed the wrong one. This would be target moved. Right? If it's less than 50, then the target has not. Wow. We may want to change the name of this to target is stationary. Just for clarity. Let's go back and change this. Target stationary. I think that'll make more sense. So if the target is stationary, we're going to return true. Otherwise, we're going to return false. So if the distance between its last known location and its current location is less than 50, then we're going to say it's still stationary, and that is true. Otherwise, the target is false. The target has moved. Okay, so let's go back and then let's just double check our tree. So this is going to be target is stationary. Okay, and if the target is stationary, we are going to abort. Is that what we want? No, we want the inverse in this case. All right, let's try. So here's the deal. If we are Man, that guy looked right at me. Okay, he's not waiting too long. That's good. Actually, he's not waiting any time at all. I'm also not seeing any of our prints. So either this is aborting all of the time. Oh, it is. It's aborting all of the time, but it's never hitting. Let's not abort. Let's see something here. Wait. Okay. Wow, he's persistent. We have definitely broken something. Wait time should be 5 seconds. And in here, we should also be printing. But this is never even happening. We're not even coming in here. And that's because our condition is showing that we're stationary. It's probably needs to be stationary. This is going to be a little bit more complicated. Because what we want is we only want this state to happen after we've set ourselves up in a position. Ooh, AI is fun, dude. All right, well, we have reached the end of today's live stream. For those of you that joined, thanks Danny McGee and Zem the Tem. That was awesome having you all here. For anybody else, if you have any questions for next time, just throw those in the comments down below. I'll try to check those out beforehand. Our next stream is going to be Wednesday morning, and then we'll have another one the following Sunday, and then the following week will be pre-recorded. But for now, I will see you all hopefully Wednesday morning. Have a great week, everybody.